This is a public service announcement on cloud seeding brought to you by Richard Budop, Micah Demand, Alicia Freeman, Claire Jess, and Mark Leshock.
Cloud seeding is the altering of the hydrologic cycle, in which chemicals are sprayed from a plane at high altitudes, which pull water molecules together to form clouds and influence precipitation in a certain region. There are two main types of cloud seeding. Cold cloud seeding works through the combustion of silver iodide acetone solutions, or by burning pyrotechnic flares. What is called ice nuclei are formed. Ice nuclei are extremely small particles of silver iodide, which are known to increase the probability of ice crystals forming in the atmosphere at temperatures below -50 degrees Celsius. Dry ice or evaporating liquefied gases create this condition. Warm cloud seeding works through introducing additional nuclei into the atmosphere. The additional nuclei allow water particles to attach to them. The size of these water droplets is normally larger than the droplets formed in natural clouds. The larger size of these droplets help to promote the collision or coalescence process.
In order to fully understand cloud seeding, it is important to first understand its history. It all began in the early 1800s when a U.S. meteorologist, James Pollard Espy, proposed burning forests to produce rain. This would work because latent heat released by condensation of the vapor in clouds would result in a considerable expansion of the air, providing the energy for continued rain and upward movement of the clouds. This essentially makes use of the condensation precipitation section of the water cycle. Although Espy did not draw any conclusions leading directly to the work of modern-day theory, his attempts and hypotheses helped pave the way for the acceptance of later work. In 1902, a scientist by the name of Charles Mallory Hatfield developed a mixture of 23 different chemicals that attracted rain. By releasing these chemicals into the atmosphere using evaporation towers, rain could be induced. When it worked, though, this often caused large amounts of flash flooding. By World War I, many scientists were experimenting with Hatfield's method by dropping chemicals into existing clouds from airplanes. This would show more signs of success and is the method most widely used today.
An obvious advantage of cloud seeding is the potential to create rain. This method is not a replacement for natural forms of rain. Rather, it is intended to be used in areas experiencing severe drought. Cloud seeding may result in crops being able to grow in areas known for drought that previously could not support crops. This in turn could result in economic growth because farmers will be able to grow crops in places that they previously couldn't, which in turn will help the economy. Since cloud seeding is a method to regulate the atmosphere's water vapor, cloud seeding could also help to ensure crops will not be damaged due to hail or wind from severe storms. In 2009, China claimed to have used silver iodide to help induce a snowstorm, one of the biggest in recent memory. Cloud seeding has also seen long-term sustained success in Australia, specifically in Tasmania. Cloud seeding projects performed by the Commonwealth Scientific and Industrial Research Organization in Western and Central Tasmania have seen precipitation increases as high as 30%.
Like any scientific venture, cloud seeding must be tested to identify any possible detrimental aspects. One concern is the health of the hydrologic cycle. Cloud seeding has the potential to cause severe droughts in areas because the water molecules were wicked away to hydrate another area. In essence, when you take water molecules and combine them together to form clouds in one area, another area misses out. Eliminating natural precipitation distribution has the possibility of affecting the climate. Another concern is whether the nuclei and chemical compounds released into the atmosphere will affect organism health. According to the silver iodide MSDS sheet, the chemical's health hazard has a potential of 2. Will the nuclei and silver iodide alter the properties of water that we critically depend on for survival? How toxic is silver iodide to organisms in high quantities? How often should cloud seeding tactics be employed? More testing needs to occur before cloud seeding can be employed.
In 1915, Charles Hatfield was hired by the city of San Diego, California, to help end the ongoing drought. He constructed an evaporation tower to induce rain in the area. The following January, 30 inches of rain fell in a massive downpour, causing the Mission Valley to flood. This flash flood destroyed 2 dams, a farming community, and a number of homes and businesses. The death toll was estimated at 50. The concept of cloud seeding is not that new. Weather modification techniques like cloud seeding have been employed for hundreds of years with moderate rates of success. Current cloud seeding techniques are successful, but at what cost? While we may indeed invite more precipitation in areas that do not receive much, we also influence climate change. There are as many, if not more, concerns expressed on the topic of cloud seeding as there are positive effects possible. Much more research and testing must be done to fully understand cloud seeding techniques before mainstream implementation.